Și acum, în continuare, pentru că tot s-a vorbit aici despre fabrici, despre optimizare, probabil că e de interes ce urmează să prezentăm și cine urmează, de fapt, să vă prezinte. Cum funcționează un tool pentru digitalizarea fabricii? IFM MONEO, de fapt, este o platformă care combină nivelul tehnologiei de operare cu nivelul tehnologiei de informații, tehnologiei informației. De fapt, datele senzorilor generate în fabricile de producție pot fi citite și mai apoi procesate cu ușurință și utilizate ca bază pentru decizii durabile, pentru decizii sustenabile, că tot s-a discutat aici și despre acest lucru. În continuare, îl invit, tocmai pentru a afla mai multe despre acest tool, MONEO, pe Jean-Remy Fromentin, pentru o prezentare. I will switch to English. Thank you so much for being here. Thank you so much for your presence. I think that you need this microphone.
Oh. Thank you very much. Yes. How should I move the slides with the button here? Okay. So, thank you very much. Thank you, Marius, for the invitation to come and give a speech. I'm very happy to be here. I could have been also at the SPS fair, but I prefer to be face-to-face with you, especially because I was also here last year, but it was COVID time, so unfortunately there was nobody. So I think it's much easier to do it this way. So, as I was presented, I'm a sales and marketing director for the Industry 4.0 solutions in IFM. I'm corporate, reporting to the CEO of the company. And basically what we call Industry 4.0 solutions, that's everything which is linked to condition monitoring of equipment, energy consumption, and process monitoring, so quality of the process monitoring. So that's topics that have been discussed in the previous speeches. As you can understand also from my accent, I'm French, I'm not German, so that makes a little bit different, but this is an international company. I will give a first introduction, very small introduction to IFM, and then I will dive into one topic, only one, that I have chosen to give an illustration of what we mean by simply made for you. So the word simple is very important in our mind because we are in a world of complexity, as it was explained by Ed Morrison in his speech. So more and more technology, and the people, they tend to be in a difficult situation in front of these technologies. So this is the whole idea that we try to achieve to make it as easy, as simple as possible for the users to use complex technologies which are sitting in the background. Yeah, so IFM is an international company which was founded in Germany more than 50 years ago, 1.3 billion euro, with close to 8,500 employees. So as most of the companies, that's exactly the same as for Phoenix Contact, for instance, we're investing a lot of our turnover in R&D. That's more than 10%, 10-12%, because this is, we're talking about high technologies in the background. And we are working direct with all our customers. So at the moment, we have something like 180,000 customers, very small customers to very big ones like Ford or Renault, which have been presented before. So we are not only sensor suppliers, as most of the people know us on the market, but with the time, we have increased our portfolio to a large variety of different topics. And my topic is a little bit more focused on the software solutions, which are on the bottom right part. But you see that there are also many other technologies which can be used in automation. And of course, we serve a lot of industries. So automotive industry was in the past our #1 industry. Now we have more and more other industries which are raising up, like food and beverage, like water treatment, for instance, which are also critical industries for the sustainability of the world. So just to describe the architecture, which usually we are promoting, but this is something which we find out also from various implementations. That's not very specific to IFM. At the bottom, you have more and more on the shop floor intelligence sensors. And even if in the factories, some people, they don't know that they're using intelligent sensors very often because these technologies are not new. You have a lot of information that you can capture, that you can collect from the sensors. It is exactly the same for actuators, by the way. And we're using a protocol which is called IO-Link, which is a digital point-to-point protocol to collect all the data from the shop floor. And this is where our strength is, that we are a data source provider, because we provide this data either for the PLC or for the IT systems which need this data to be able to do some analysis and KPIs and all these things. The second point is the split between OT and IT. So we know that the use of data is not the same in OT, so for robots, PLCs and so on, than in IT. So when you speak about CMMS or any ERP which is using the data or data lakes, the use of data is not the same at all. So this is a reason for the split, but it's also a split which is due for cybersecurity. We don't want to have anybody from the IT side coming and hack the OT, so the PLC, because it's the plant manufacturing which doesn't have to be stopped and doesn't have to be hacked by people coming from the IT side. So this is a split, and of course we use different protocols for each one of them, the OT and the IT world. And then you have the application layer and the cloud connectivity, so there's nothing really new in this. So we are primarily focused on condition-based maintenance and predictive maintenance tools, but also on energy quality. What we mean by quality is most of the time quality of the manufacturing process, and track and trace also, which is a very important topic in Industry 4.0. So for this we have an IIoT platform, which we call MONEO, that you can see here on the right side. So if you have time, you can come and see the software with a very nice demo. And basically it's doing collecting data, visualizing, notification, analyzing. So that's something that you find on a lot of IIoT platforms. So from this point of view, this is not something which is new on the market. This is something that we try to make very easy to use. And I will take one example to explain why it is easy to use and how we could achieve that. So everybody's talking about artificial intelligence, but artificial intelligence is basically just a set of mathematical algorithms. And everything depends on what you want to achieve, by the way. And we decided to do smart monitoring of the condition of equipment, so to bring a little bit of intelligence to the existing monitoring, which we already have for many years, using data science tools, but in a way that non-experts, everybody can use it very, very easily. So that's basically the target that we wanted to achieve. And we did that by, so we bought a company, a data science company called StatMat 3 years ago, and we asked them to bring all their knowledge into the software and to make it as easy as possible for users. So the first tool that we have developed is very easy to understand, because this is something that you're using on your car nearly every day. So this is the lane keeping assistant. So you know that when you're getting out of the lane with your car, you have a warning signal. So either vibrations in the steering wheel, or you have a sound, or you have something which tells you you're deviating for the normal process, which is staying on the line. Except, of course, if you put the left or right signals. So this is exactly the same that we're trying to do with the monitoring of a process on a given equipment, a given machine, by keeping the machine in the lane, or saying differently, giving a warning signal every time that it's going out of the lane. And to figure out this, there is a very simple chart here. So you may have the standard condition monitoring systems, which are usually looking at the target variable, so any data source or calculated data source, and you have usually a lower threshold or a higher threshold. And every time that you're going over the threshold, you have a signal saying there is something wrong on the machine. So what happens if you have a target variable which is doing like this? You do not notice. The system is not telling you that there is something wrong because it's not visible. You do not exceed any threshold. With the use of data science, what we're able to do is to look at the dynamic process. And with this dynamic process, to notice that every time that the target variable is going out of a confidence bound, then you raise an alarm. And of course, the system needs to learn what is a standard process, what is the normal behavior of a machine. So we have a tool to help learning what is the best behavior of the machine. And to make it, again, very easy, very simple for everyone to be able to use it, we have a wizard. We have designed a wizard with 5 steps. So the first step is, of course, to define the target variable. So for instance, let's take the example of a pump. You will say, I want to monitor the outlet of the pump. So the outlet flow of the pump. And this outlet flow of the pump, I have to select the period of time for which it's behaving normally. It could be fluctuating, of course, it's a dynamic process. And I have to understand also all the influencing factors that have an influence on this outlet flow. It could be the inlet flow, it could be the temperature, it could be the pressure, it could be vibration and bearing conditions. It could be a lot of different data sources which are influencing this target variable. Then the system is automatically learning from the existing database of these influencing variables. The system is automatically learning with 3 different algorithms. So we're using decision tree, we're using neural networks, and the system will suggest the best fit model. So you don't have to be a data science expert. The system is the data science expert and will provide you with the best fit system. And the system will even tell you which of the influencing variables are the relevant one. That means you have selected 10, 100 influencing variables, and the system will give you a factor of between 0% and 100%, which one is the most influencing. And then at the end, you just set the confidence bound, and that's it. So let's say in 5 minutes to half an hour, because sometimes we need a lot of computing power to train the model, you're able to set up a complete data science tool to have a dynamic process monitoring. So that's very easy. I can give you an example because we had a customer who wanted to monitor a conveyor belt. So on a conveyor belt, the problem is that most of the time you have a lot of drives along the conveyor belt. And of course, a single motor which is failing as a consequence on the whole conveying situation. So that can be really, really critical, especially when you are in industries like these big logistic areas, like the Zalando, the Amazon, and so on. Whenever they have a conveyor which is stopped, this is a big problem. We have also typical examples, because I'm talking about Zalando and Amazon, but we have also airports for the delivery of luggages, for instance. So there's a lot of places where it's very critical to have a conveyor which is always running, never stops. And the tool that we use is to monitor all the drives on the belt to give an early warning signal that something is getting worse before we have a failure. And for that, this is a complex application because not every motor is the same. from its condition on the one hand, but also from the speed of the motor. You may have different speeds along the conveyor belt, and that makes it very complex to monitor as a complete installation. So what we do, a little bit more technical, sorry for that. What we do is monitor the A peak, so this is the average peak, on one motor, which is usually the last motor on the conveyor belt. And we use as influencing variables the A peak of all the other motors, whatever the number is. And the system learns from all the data that we are collecting from these various drives. And at the end, when the system is running, so you can see here the result of the 3 algorithms which I'm using. The accuracy is quite good because it's between 92 and 94%. So the relevance is good. Basically, whatever system I select, it would be very similar. And that's a real case result. And the system will always tell you the prediction of the value, so what the value should be according to the mathematical model which is used by artificial intelligence, and the real measured value. And by looking at these 2 values, you can detect a drift in the process. So that's quite simple to understand. Of course, there's a lot of complexity in the background, you can understand that. So that's comment from the customer. It's an Italian customer in the packaging area for which we implemented the system, so in a very straightforward and quick way, saying like it's like magic, because very easily you can learn, you can do this data science algorithm, use them for a specific application and get a very early result. So of course, because we also have ourselves a data science company in IFM, we know a little bit what it means. They are working also on data science project. So data science projects have some benefits, but compared to this solution, it's also more expensive. It takes more time. Usually the benefit is that the probability for a good data system for a given equipment is higher, but on the other hand, it does not allow you to do a quick test which tells you, okay, that works fine, and I can continue, or I should forget about that because I don't get any result. And this is a problem sometimes of some data science project, that it takes a long time, many months, a lot of money. The typical entry cost is 20k euro, but it could be 60, 100 or even more K euro for a project with, at the end, sometimes no result or a lot of time and resources. With this MONEO smart limit watcher, the cost is very low and you can try it. So at it's not time consuming, it's not expensive, and you can do a try. So this is the idea of trial, fail fast in case that it does not work, but also being very efficient to select the right one. So there are also other tools which are available. So the pattern monitor, for instance, is just checking, it's easier. It's checking the erratic behavior of a process or sudden changes or a drift on one target variable. So this is something that we have in field test at some customers at the moment, but also we already had some experience like the lifetime estimator, so estimating the remaining lifetime of an equipment. So this is something which is very important in the area of condition-based maintenance and predictive maintenance. So we already have some projects, but the idea is once again to bring it into the software as a simple tool that anybody can use, and not to consider it as a data science project costing time and money. So, thank you. That was very focused on one topic, and I'm available today here if you have any question. Thanks a lot.
Thank
Thank you. Thank you so much.